So when we're looking at these graphs, and again, we're going to graph each of these so we get practice graphing it, but now we have a number that's inside the function. We've got 6 times x inside cos, 2/3 times x inside tan, 1/7 times x inside sine. What does that do? It's going to be a horizontal stretch or compression. With the 6 inside cos, what are you going to multiply your x values by? 1/6. So if we start the same way for graphing, so here's A. This time there's just a 1 in front of cos. So what's our amplitude going to be? Our amplitude's going to be 1. In fact, that makes sense because our y values are not getting changed. Now normally what we did is we marked a spot along of our x-axis and marked our period. And our period starts off at 2 pi. But now what's going to happen is your period, which was 2 pi, is going to get multiplied by 1/6. So now instead of writing 2 pi here, I need to multiply that 2 pi by 1/6. And if I do that, I'll get 2 pi over 6. You could reduce that to pi over 3 if you wanted to, or we could just leave it as 2 pi divided by 6. Because I normally had 2 pi, but now I multiply my x values by 1/6. So I'm going to have 2 pi over 6. Again, we still divide this into 4 equal sections, but now we're going to have to do some mental math to figure out what those 4 sections are. When I'm figuring out those 4 sections, I like to find the middle one first, because the middle one is going to be half of this. And what's half of 2 pi over 6? 1 pi over 6. Excellent. And then I like to find the first one next, because it's just going to be half of pi over 6. Half of pi over 6 will be pi over 12. And then once you find the first one, since all of these are equally spaced, in theory, my drawing looks like this one's a little bit shorter. But this is 1 pi over 12. This is 2 pi over 12. This one will be 3 pi over 12. And again, if you wanted to reduce that to pi over 4, that would be fine, but you don't need to. And I like writing it this way because it's easy to count, and then you know that you've got the right values. So now that we've marked one full period and split it into 4 equal sections, we ask ourselves, well, where does cos normally start? Maximum, a minimum, or on the center line? Cos starts at a maximum. So we have our starting point, and then we can just go from maximum to center line to minimum to center line to maximum. So as you can see, we're developing a shortcut for graphing. In transformations, when we did our graphs, we would take 2 or 3 points and write those points out and then say x by 1/6 and see where that point went. But for sine and cosine graphs and tan graphs, we can take the key things like the period and say, what happens to that period? And then we got all 5 points quickly instead of having to do those calculations individually for them. So it's really nice. As a result, the period of this one is 2 pi over 6 or pi over 3. Now for tan, our period was pi, and we saw that period by looking between our asymptotes. So when we're graphing this, where the x values are going to get multiplied by the reciprocal, the x values are going to get multiplied by 3 over 2. We're going to start by looking at those asymptotes. We had an asymptote here that was at pi over 2. And if you multiply that x equals pi over 2 by 3 over 2, because that's the stretch that's happening, our new asymptote is going to be at pi over 2 times 3 over 2 will become 3 pi over 4. And similarly, the one on this side will become negative 3 pi over 4. And if you took the asymptote that was here, which was at 3 pi over 2, and you multiplied that by 3 over 2, you're going to get 9 pi over 4. So notice when you're graphing these, we're not worried about making our scale all of a sudden. We define our own scale. So your graphs could look very similar to what they did before, but you've made a new scale along the way for drawing it. Now that you have your asymptotes, what does a tan graph look like? Looks like an x cubed graph. And this would be fine. Put 1 on the y-axis just so you have it labeled. So our period for tan was pi, and now it's been stretched because we've multiplied our x values by 3 over 2. So now our period for this one pi times 3 over 2, 3 pi over 2. And you can see that from the graph. If you would go from 3 pi over 4 to 9 pi over 4, you've gone up 6 pi over 4, which reduces to 3 pi over 2. And the last one was sine of x over 7. What's that going to do to our graph? Big stretch. We're going to multiply our x values by 7. So again, when we go to graph sine, there's a 1 in front, so we know that our amplitude is 1. We can mark 1 and negative 1. And our period was normally 2 pi. But since we're multiplying by 7, instead of starting off with 2 pi times 7 will be 14 pi. Again, divide it into 4 equal sections. Half of 14 pi, 7 pi. Half of 7 pi, 7 pi over 2. And since one section is 7 pi over 2, the third one will be 1 7 pi over 2, 2 7 pi over 2s, 3 7 pi over 2s. 3 times 7 is 21. So this will be 21 pi over 2. Where does the sine graph start? Center line max or min? Right in the middle. So we start in the middle, and it starts in the middle going up. So we go from center line to maximum to center line to minimum to center line. And our period is 14 pi. C and D deal with changes to your period.